Good evening, everyone. Today's session is on AI project cycle. What is AI project cycle? It is artificial intelligence project cycle. How we are basically building the software that are AI enabled, and what are the different steps that needs to be taken while building AI softwares, right? So let us begin with the session. So these are the 5 steps that need to be taken while building an AI project, right? First is problem scooping. First stage is problem scooping. The second stage is data acquisition. Third stage is data exploration. Fourth, modeling. And the last stage is evaluation. So I'm taking one example and applying the AI project cycle to it, so that to make you understand like how we apply AI project cycle in our projects, right? So let us begin with the session. I have taken one scenario in which daily people are like eating food outside, and the restaurant owner is preparing the food, and the problem that is faced by the restaurant owner is wastage of food at the end of the day. So we have seen like 1.3 billion tons of food production are wasted every year, right? And that's one third of the world's food production. More than 820 million people do not have enough to eat today, right? And we have the wastage of food at the same time. Now, waste happens all along the supply chain from the production stage to the final household consumption. So the problem of the restaurant owner is like daily we have a leftover food which is not consumed by the people, right? So we know that like daily the restaurant owner is preparing some quantity of food, and that is left at the end of the each day, and the same quantity is like something is consumed and something is waste at the same time, right? Now he wants to have a predictive model that is going to predict how much quantity of the food should be prepared each day, right? So now let us move to this case study. What are the different factors we need to assume? What are the things we are going to apply? How we apply AI project cycle to this problem statement? And this is mainly for predicting the quantity of the food that is prepared per day, right? So first stage I told you, that is problem scooping. Now whenever we have the first, like what is the problem? That is to identify the problem which is arising, and we are going to apply AI project cycle to it, right? There are 4 W's in this prob problem scooping canvas, right? The first is who, the second is what is the problem. One by one I'm going to take it, but let me give you a brief it to it. That is who is having the problem, then what is the problem is about, where this problem is arising, and the last part, why this problem is arriving, what will be the ideal solution for this problem, right? So we have seen the in the given scenario, the problem is the daily leftover food, right? So who are the stakeholders? The restaurant offering buffets or restaurant chefs, they are facing the problem. What do you do we know about them? So restaurant cook food in bulk every day for their buffets to meet their customer needs. They estimate the number of customers that would walk into their restaurant every day, and at the same time they have this thing, but at the end of the day they are facing the problem. So what canvas tells you about what is the problem? So quite a large amount of food is left over every day unconsumed at the restaurant, which is either thrown away or given for free to needy people. So the most important point is the restaurant owner is to bear the losses, that is every day, for the unconsumed food. right? How do you know is it a problem? Because restaurant surveys have been shown that restaurant face problem of food wastage that we have seen in the first slide. Okay, these number of people are facing, like every day we have a leftover food, and every day the restaurant owner is facing the same problem. So let's move to the next part where this problem is arising. Now, where does means where this problem, like this is obviously this is arising in a restaurant which serves the buffet food at the end of the day when no further food consumption is possible. Now, when there is no food consumption at the end of the day, obviously the food is left. Now, let us see why and giving a worth solution to this problem. So, in the why part, you are going to write down what could be the ideal solution for solving the problem, right? If the restaurant owner has a proper estimate of the quantity of the food to be prepared every day, the food waste can be reduced. If he knows like these number of people are coming to the restaurant and uh, taking the food, right? So according to that, the restaurant owner is going to prepare the food, so that what is the solution to this is so that it can make the same quantity, which is basically at the end of the day nothing should be left over as unconsumed food, and obviously the losses can be minimized through this model. So he want to predict the number of quantity of food that is to be prepared for each day, right? Now, this is very important for the problem scooping point of view, where we have a 4 W's canvas which is holding all the W's and the complete in all the respects, that is the shortcut of problem scooping. So what we have to derive, this template we need to derive, right? The first talks about who is having the problem, the restaurant owners. What is the problem? The losses due to food wastage. Where this problem is arising, the food is left unconsumed to the improper estimation in the restaurants. Why this problem? Now you have to give an ideal solution to the problem. To be able to predict the amount of food to be prepared for everyday consumption. So the restaurant owner wants to have a predictive model which is going to predict the quantity of food dishes to be prepared for everyday consumption in restaurant buffets, right? So this is the first stage when we define the problem. This is the first stage of AI project cycle. Let us move to the next step, that is data acquisition. Now, according to the problem statement, we have defined, we have seen this is the problem. Now to apply the second stage where we need to collect the data, acquire the data. Once we have defined the problem, the next step is to collect the data, to capture the data. Right. Now, what are the different factors that are involved in capturing in the data? That are total number of customers. Every day, how many customers are coming? Quantity of dish prepared per day. What is the quantity of dish to be prepared per day? Then, how much dish is consumed? That is dish consumption. Next, unconsumed dish quantity per day. Now you need to maintain this part also. How much dish to be, basically how much dish is unconsumed per day. That quantity is also maintained to know, that is given as an input to the model also. Most important factor, price of the dish, right? Then quantity of dish for the next day. What for the next day, how much quantity to be prepared for the dish. So these are the 6 factors which we have analyzed could be there to solve this problem. So let us move to the next phase, and only the clean data, means not all the factors are to be used in the coming model. We are going to use only the important factors which are basically influencing the problem. So the third stage is data exploration. After creating the data, after we have collected the data, we have seen there are 3 important factors. What are those? Name of the dish, quantity of that dish prepared per day, quantity of unconsumed portion of that dish per day. So now you need to maintain one database where you need to write the name of the dish, quantity to be prepared per day, और उसमें से how much it is left, quantity of unconsumed portion of that dish per day, right? So starting with huge problem, coming to the smallest one, how it is possible? You have identified there are 6 factors. Now from these 6 factors we need to select only those factors which are directly influencing your problem. So the 3 factors which are identified in this is name of the dish, quantity of that dish prepared per day, and the quantity of unconsumed portion of the dish per day, right? Now let us move to the next part, that is modeling. In the modeling phase, what we do is basically, once the data set is ready, once your collected data is ready and you have cleaned that data set also. Cleaning means you have 6 features, you have extracted the most important one. Cleaning means this thing, right? The most important, the most closest factors which are actually influencing your problem statement. Right, now you have analyzed these are the 3 factors which are directly affecting your problem. Now once the data is ready, we train our model. So in our modeling phase, we are basically training our model on the with the help of data. In this case, a regression model. Why we are choosing a regression model? Because a regression model is basically used for continuous data. It is used for values that are continuous. It is not a classification technique. It's a what? It's a supervised learning model which basically which works on real values, right? Whereas when we have classification type of thing, it works on categorical type of data. So when we have real values, when we have values to be evaluated, then we are going to use the linear regression method. So let me give you a brief introduction to regression. Regression is a supervised learning model which takes in continuous values of data over a period of time. So I told you it works on values. So that means continuous values of data over a period of time. Since in our case the data which we have is a continuous data of last 30 days. So what the restaurant owner has decided, like he is going to take, he want to train the model with the last 30 years of data set, because you need to train the model with some because the AI systems are basically working on data sets. They have the data, they identify the patterns in the data, only then they are going to work, right? Since we are using the regression model so that it predicts the next values to it in a similar manner. In this training and testing data, in this case data of 30 days is divided into in a ratio of 2:1 for training and testing respectively. In this case the model is first trained on the 20 days data and then gets evaluated for the rest 10 days. So what we do actually is we basically divide the data set into 20 to 30 ratio. Why? 80 is required for training the model and 20% data is used for evaluating the model, for testing the model. This is basically why we are doing so. At the same time, like AI learning models have the same thing. Once you train the model, the other thing is you test the model also, right? Like you have taken 30 days data. Now 20 is kept for training the model and 10 days are kept for 10 days data are kept for testing the model, or it basically evaluating the model. Now after evaluating this, the last step of AI project cycle is what? Evaluation, right? Let us move to that. So what is evaluation? Evaluation is once your model has been trained on the training data set of 20 days, it is now time to see if the model is working properly or not. Let us see how the model works and how it is tested. So I told you it is basically having the ratio that is 80 to 20. 80% of data is used for training the model and 20% data is used for testing the model. Step 1, let us start with this evaluation part. Step 1, the trained model is fed data regards the name of the dish and the quantity produced for the same. So we have taken only three factors, right? What are those three factors? Name of the dish, the quantity of dish prepared per day and quantity of leftover food, right? The second step is it is then fed data regards the quantity of food left unconsumed for the same dish on previous occasions. So now it is going to check earlier with the same dish how much food is left. Then step 3, the model then works upon the entries according to the training it got at the modeling stage. Step 4, the model predicts the quantity of food to be prepared for the next day. Now it is like that based on your three factors, right? You are training the model. Now based on these factors, you are training the model and you are checking it at the same time whether it is giving the accurate output or not. Now this is the last step of this part. Step 5, the prediction is compared to the testing dataset value. From the testing dataset, ideally we can say that the quantity of food to be produced for next day's consumption should be total quantity minus the unconsumed quantity. So this is how we use this thing, right? Like in step 6, the model is tested for 10 testing datasets because we have kept it aside. We have not taken it from the training dataset, right? What we have done, suppose we have 30 days data, we have taken for training the model, we have taken 20 days data set, and for testing the model, now we are evaluating the model, that is with the help of testing data set. And what is the test duration of testing there? That is 10 days. Right, and within this part we may use a train test split method also, or we may use cross validations method also. So any method can be used for evaluating the system. Step 8, if the prediction value is same or almost similar to the actual values, the model is said to be accurate. Right, like suppose I have predicted 4 kg of this dish to be prepared. The machine is predicting, and in actual also it is 4 kgs to be predicted, and there is no leftover food at the end of the day. Obviously it is giving the accurate results as well, right? Otherwise you need to change the algorithm. So we have taken the algorithm, that is regression, for solving this problem. If the model is giving you inaccurate results, that means you need to change the selection of the algorithm, right? Otherwise either the model selection is changed or the model is trained on more data for better accuracy. So you have two things. When the results are inaccurate, you need to change two things. Either one of the thing, either change the algorithm or increase the data set, right? So in this case, like we have already trained the system with 30 data set, and we have evaluated as well. Like 20 is for training the data and training the model, and 30 out of 30, 10 is kept for testing the data, right? Once the model is able to achieve optimum efficiency, it is ready to be deployed in the restaurant for real-time usage. So this is how basically your AI project cycle works, right? It is not like this ki you have to have an accurate output while you are training the model. No. Sometimes you may face the problem of having inaccurate results. So the solution to this problem is either you need to change the algorithm like we have used in our case, that is regression, or you may do one thing, that is you can increase the data. Like if we have taken for 30 days data, we might be taking for 60 days in that case. We are not going to use for 30 days only, right? In order to get the accurate results. So this is how we are using AI project cycle and how we are using the different stages in our project. Right now, like somebody asks you why we are using only regression or why we are using the evaluation methods. So they are predefined steps, you cannot change it. And the most important thing is you cannot change the sequence of this step. This is the cycle na? You cannot say after problem scoping I'm going to evaluate the model, right? So this is basically done in a sequence. There are these steps are in ordered format, and we need to follow the same sequence. We cannot say that you can do this thing in parallel, but you cannot say this before problem scooping I am going to collect the data. You may say this thing problem scooping at the same time we are collecting the data because we know the problem. This could be possible, but this cannot be possible. You can leave any step or you can directly jump into the third step. No. So these are the mandatory steps to be followed while applying AI project cycle to any project. Right? So what are these three steps? The first is problem scooping. The second is data acquisition. The third is the third is data exploration. Fourth is modeling, and the fifth is evaluation. Right? And under this, again I am repeating, in problem scooping, there are 4 W's canvas. What are those 4 W's? What, where, who, and why. In data acquisition, we have, the most important thing, when we are collecting the data, we can collect the data through online or offline sources. Right. So online sources may, like, you have certain government websites through which you can download the data set, and they are open source data sets. You need not have to purchase those data set, right? And offline sources may, you may collect the data of cameras, footages, or sensors, or surveys you can do, or you may say APIs, templates you may use, or there are this one more thing is there, that was like when you are making any website, that is, but it is an online website only, you may have different website for capturing the data. What all are those? I'm giving some example: kaggle.com, data.gov.in, or UCI machine learning library, GitHub databases are there. So there are number of sources from where you can collect the data. So once you have collected the data, the next step is to explore that data. Explore में you are basically visualizing. We use different tools like Power BI or Tableau or MS Excel. There are a number of tools that can be used for visualization of data based on the type of data we have. If we have a categorical type of data, we may be applying those types of chart. If we have quantitative data or numeric values, we may be using some other type of data. Then what we are going to do is, once we have that data set, what we are going to do with that? We model the system. We train the model, right? And once we have trained the model, the next step is to evaluate the testing of that model, whether that model is giving us the accurate output or not. If it is not giving the accurate output, then return to again to the modeling phase or to the data acquisition phase to again collect the data, increase that amount of data set. Like if we are taking the data set, increase the amount of data set, or the next thing is change the algorithm. So in the coming videos, we will be discussing on what all are the algorithms that we have. Like we have talked about only regression. What about the other algorithms like classification, or when to use classification algorithm, when to use this regression algorithm. So there are a number of things we will, or why we don't use ensemble techniques, how to calculate the loss or errors. So in the coming videos, we will be learning about these algorithms as well. so that we have a clear picture whenever we have any problem statement, how we are going to solve it, right? And at the end of the part, like evaluation phase, we have different evaluation methods. Evaluation may only not only you are calculating the accuracy, you may be calculating the F1 score, which basically predicts whether your model is giving optimum usage or not, and it is accurate or not, right? So in evaluation, we may have different evaluation methods through which we can evaluate the model, and it could be a accuracy formula, it could be a precision, it could be a recall, or it could be after for you after calculating all these three methods, we can calculate the F1 score for our model. Basically, if it tends to 1, that means our model is predicting good accuracy, and if it tends to 0, it is a poor model and you need to rework on that model, right? So this is how we have AI project cycle and how we apply this AI project cycle in our project, right? And there are other things also, like we have system maps also. So system maps basically shows you the relationship between two variables, whether they are related or not. And in modeling phase also, like in regression, before applying regression, we may need to check it whether they are correlated with each other or not. So we apply some statistics approaches for solving the problem. It may be like which type of relationship it is using for solving the problem, right? So that means we are using whether the two variables are related to each other or not, and how we are going to calculate it with the help of correlation, right? Under correlation, we have again some statistical concepts are used for calculating the R value for the relation between two variables, right? So these are the different steps that we have studied today, and the 4Ws canvas, what were, and here again very important point in a 4Ws canvas, when is not used, when is not included, right? We have included only 4Ws. What are those 4Ws? Who, what, where, and why. When is not included in our problem scooping part. Then when we talk about data acquisition part, and data acquisition, we have two sources, online sources and offline sources. After this, we have exploration, in which we basically clean the data and visualize that data. Once we have visualized the data, then we apply the modeling techniques to that for training the model. Once we train the model, then we evaluate the model with different evaluation methods, right? And once the methods are like, once the model is evaluated, it gives you the accuracy. Based on the value of accuracy, you need to decide whether to go with this algorithm only, or rework on that and change the algorithm or increase the data set, right? So this is how AI project cycle works. So I hope all of you have understood about what is AI project cycle and how we apply AI project cycle for solving our problems, how it is predicting the values, right? So in the coming series, we will be having more case studies and how to solve this, how, what is linear regression, what are supervised techniques, what are unsupervised learning algorithms. We will be learning those types also. Okay, so thank you.